All right, 4.7, 4.8 review worksheet or practice quiz. The first is asking you to determine whether each table represents a linear or nonlinear function. If it's linear, it will have a constant rate of change. If it's nonlinear, it will not be constant. So I have to find the rate of change here. I am adding 5 each time. If I add the same up here, not 5 necessarily, but if I add the same across the board, so I'm subtracting 3, subtracting 3, subtracting 3. So if these are the same and these are the same, then it is linear. They don't have to be the same to each other. This right here is 3 points on your quiz tomorrow. 1, showing what the difference is there.
How many points do you get to?
I don't actually know. Well, I have to look at it. With the explain? Is that what you said? Yep. So constant rate of change. Remember when I was doing ROC? Rate of change. Yep. So here I'm adding 1, I'm adding 2, and then I'm adding 6. The only way I will know for sure if it's not constant is if I look up here too, because what if this was 1 and then this was 2 and this was 6? Okay, the rate of change is the y over the x, so it would be 1 over 1, which reduces down to, what's 1 divided by 1? 1. What's 2 divided by 2? What's 6 divided by 6? Okay, so therefore it would have a constant rate of change because they all have the same ratio, right? But these are not 1, 2, and 6, right? These are all 2. Or adding 2 each time. So if these are the same, but these are different, then it is non-linear. They don't need to be, but if these are the same, if the whole top row is the same, then these all have to be the same. Okay? So because 1 over 2 is different than 2 over 2 and 6 over 2. Okay? Nonlinear, not a constant rate of change. Okay, here again, 3 to 8, I'm adding 5 each time. For my y's, my change is 5, so I'm adding 5. And then up here, I'm adding 2.5 each time, 2.5. You are. So is this linear or nonlinear? Alyssa, linear or nonlinear? Linear. Okay, the next one, pick a point on the box or the rectangles, say the top left corner, and connect all the top left corners. Does that look linear? No.
It's very linear.
It's very wavy, so it's non-linear.
Oh, come on.
What? A line?
How straight that line is?
Straight. Straight. No curve in the straight. Okay, number 5. A lot of people will get discouraged by a word problem. Don't get discouraged. Usually what they're asking you is the last sentence. So in the last sentence, or sentences, it says, does this represent a linear or nonlinear function? Explain your answer. All it's asking you again is, tell me if the information is linear or nonlinear. So we can figure it out from a table, right? Because we just did that up here. So we should be able to down here, but we don't have a table. So we actually have to create a table. So x, my equation goes inside here. So 2 to the x power, and then y. And for this one, because it's to the x power, I'm actually just going to use my positive. So 1, 2, 3, 4. And then it's 2, and instead of x, I'm going to replace it with 1. So what's 2 to the first power? Anything to the first power is itself. So 2. 2 to the second power would be 2 times 2, which is, thank you, 4. 2 to the third power is 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8. And then my last one would be 16 because we're adding another times 2. So if you notice, actually, all of these I'm just doubling each time. So 2 times 2, and then 4 times 2, and 8 times 2. Anyway, find the difference or the rate of change. So here all the change is 1, but on this side it's 2 to 4, which is adding 2. 4 to 8 I'm adding 4. 8 to 16 I'm adding 8. Are they different? Are they all the same or all different? They're all different. So it's going to be non-linear. Are we all okay with figuring out if it's, or telling if a relationship represents linear or nonlinear? Yep. Okay, the next one's a little more difficult. Big part on this backside is order of operations. Okay, so we're going to create a table. The table is going to be the bulk of your points on the quiz tomorrow. Being able to, so I can't talk and write at the same time, obviously. Being able to put a number into an equation, do the correct steps and the correct math to it, and then solving it. So this one, I am going to do -2, -1, 0, 1, and 2. So I like to write my equation. So -2 times x squared, and instead of x, I'm going to put parentheses. So I'm going to write that all the way down. -2. You should be writing this down if you do not have this down. You should be writing this down if you don't have this down. -2, parentheses. Did you guys ever have to write like long sentences in elementary and you just did it this way, like writing one word at a time? Never? Never mind. Okay.
Did she usually write it in the time?
In fifth grade, when I had to write an essay on a computer, when I had to be like a certain amount of words, I'd get it done and it would still be less, so I'd change the font to white and just slide on the keyboard until I got the amount that I needed.
I didn't even think of that. Okay, hold on. We got to finish this.
I remember when I did this typing thing in elementary.
And you would just push control.
No, when I do it, I just push caps. And that's what I'm doing this. As soon as I walk away, I press start. And stuff like this.
All right, so you're going to put x in here for your what you want x to be into your equation. My first thing that I have to do is my, said this before, parentheses. No parentheses, so then we do exponents. Okay, so -2 times itself. Emma, -2 times -2 is a +4. Okay, when I have these next to each other, -2 is being multiplied by whatever x is squared. So this is not -2 plus 4 minus 2. It is -2 times 4. So -2 times 4 is a -8. -8, and then minus 2, you get a -10. Okay, this is where you can use a calculator to figure out what -2 times -2 is. And then multiply by the -2. And then subtract the 2. But you have to remember the order of operations, understand? Okay. Okay, so -1, why is it -2? Because we have 4, we got the 4, but the 4 times a -2 is a -8. And -8 minus 2, so you are going even further negative. You're taking away another 8, or another 2. Okay. Okay, -1 times Negative 1 is 1 times negative 2 minus 2. Negative 2 minus 2 is what? No. Negative 2 minus 2. Negative 4. Yep. Okay, 0 times itself is 0, times negative 2 is 0. 0 minus 2 is a negative 2. You should be showing your work in here, showing that final step of 0 minus 2 is equal to. That is.
excessive.
Yeah, man. Oh my gosh. So I'm going to skip ahead because we are running out of time. And I'm going to plot my points. I only have to negative 8, so I'm going to count by 2's. So 2, 4, 6, 8, 10. So negative 2, negative 10 goes right here. Right? 2, 4, 6, 8. Oh, man. Goes to here. Okay. Negative 1, negative 4. 0, negative 2. Do you see how it's symmetrical? It is a U.
It's like an arrow.
Okay, my A is negative, so it's going to open downward. Okay, I'm not going to do number 7, but I will go on to this one. This one, same thing to graph this equation right here is 50 plus 2r squared. You have to remember order of operations. Am I going to put negative in here? No. If it gives you a graph, this is huge. If it gives you a, use numbers from that. I would actually use 0, 2, 4, 6, 8. Okay, so 0, 2, 4, 6, 8. 50 plus 2, instead of r, I'm going to put 0 in there, square it. 50 plus 2 times 2 squared. Up here, 0 squared is 0, times 2 is 0, plus 50 is 50. This 0, I have to multiply that 0 times the 2 first. You do not add 50 plus the 2, and then, no, what's 0 times 0? You have to do the exponents first.
0, then times 2 is 0 also.
Yep, so it's 50 plus 0. You have to do the exponents and then the multiplication. Okay, so the next one, 2 times 2 is 4. 4 times 2 is 8. 8 plus 50 is 58. Okay, 50 plus 2 times 4 squared. So what's 4 squared? Or 4 times 4? 16. What's 16 times 2? 32. And then I have to add the 50, which is 82. Okay, so I'm going to jump ahead here. This is 6, 36, 1, 36, 72, 1, 122. Did it really? Okay.